segment is to give you an update on our groundwater policy. And I'll talk about Protocol 21. You know we've got our new protocol in effect since December of 2015, so I'll talk about some of the changes in Protocol 21 over our old TG6. The next one's a bit of a project, more of a wannabe project, groundwater mapping. So we're always looking for partners on the groundwater mapping front, so talk about that a little bit. And then our elusive draft Protocol 5, where we're setting out groundwater remediation requirements. I'll bring you up to speed on that. And I have a sneaking suspicion if Alan's going to have any time to talk at all, I'll have to skip Tech Guidance 22, and there's really not much to say about Tech Guidance 22 anyway. So Protocol 21, yes, we had our previous version was in effect from July 2010 to December 2015, and as you all know, that was kind of a radical change in how we made determinations of water use. And almost since the day it was passed, we started working on introducing greater leniency under that technical guidance, and a lot of that was just gradually introduced over the years until really by the time we were ready to pass Protocol 21, most of those changes had already been put into effect. And the APs here were informed, maybe not all of you, but anybody who is working on these water use determinations in an active way would have been knowledgeable of the changes that were allowed. And there were a few last-minute changes, so really nothing dramatic, but they are significant. Over the course of time, there have been some significant relaxation introduced into Technical Guidance 6, which is now, just like the vapor guidance that Peter was just talking about, parts of it will go into protocol. The water determination, the components that really dictate where the standards apply. So to have consistency and fairness in the regime, we need the standards, and then we need consistency on how those standards apply. So just going back to the fundamentals, just humor me here for a little bit, but it's always good to talk about the roots in the regulation. So P21, just call it P21 from now on, provides criteria for determining water uses and water standards for assessing contaminated sites. There's 4 standards. They're set out in section 12.4. These are the sections in the regulation that talk about determining contamination. And those water uses are drinking water, irrigation, livestock, aquatic life. And then we just have this funny category that as a process of elimination by how we determine water uses, we end up with a no specified use. And it's not rare. I mean, it's quite common. It used to be really common under old TG6, but it still occurs quite commonly under new TG6 since 2010 and Protocol 21. That's unique for all of the media. We don't have a no-use category for any other media, and it creates problems for us because we have no standards that apply to that category. And so it was the impetus for moving towards more clarification on having uses, having defined uses apply more broadly to groundwater to protect the groundwater. The factors that the director has to consider in the regulation for assigning a water use, and this applies to all the uses, but I pulled out what's specific to water. So at the highest level, it's in the regulation that the director has to think about current and reasonable potential future use. So we often talk about reasonably anticipated future use because that's what the regulation says the director has to consider. And then below that, some of the subcategories are protection for use at the site and the neighboring site. That's now, and that's this reasonable use in the future. Prevention of pollution. Pollution is impairment of the resource, just to pull that out of the definition in EMA. And policies of government. So policies of the provincial and local governments as well are considerations. So one of the pieces that's behind the work that Land Remediation Section has been doing on setting guidance around how we protect the groundwater resource is our consultation with our colleagues, our brethren in the Ministry of Environment that are charged with managing that resource, the groundwater resource. So this is our Water Protection and Stewardship branch. that have just brought into force the new Water Sustainability Act. So those are really clear policies of government in legislation now, and we work very closely with our water protection and sustainability branch whenever we're working on these new documents to make sure that there's consistent with the direction that they have, and they're actually a little behind us, so we're ahead of the game. And we're hoping that when they finally introduce their regulations to set out water objectives, that they'll be adopting some of the work that we've done already, or at least are in this consultation that we have had with them over the years, that there'll be good alignment between where they're going and where we already are. So some of the changes, there's been, most of it's all relief. There's just a couple that are tightening up, but mostly it's all relief right through the document. So for shallow aquifers, we've increased the exemptions considerably for shallow aquifers. So if the saturated thickness is 2 meters, it used to be 1 meter, now it's 2 meters. If the shallow aquifer is comprised entirely of fill, then we're not protecting it for drinking water use. Remember, shallow aquifers can only be considered in isolation of a deeper aquifer if there's a natural confining barrier, and you can see that in the schematic. In this case, the fill at the surface, it's fill, so it ends up with no drinking water use, but it's allowed to be assessed separately from the deep drinking water aquifer because there's a natural confining barrier in between. Irrigation and livestock water, we used to have a future use for irrigation and livestock water. Now DW, drinking water, is the surrogate for all future uses. And that's because we've got a greater number of standards for drinking water, and by and large, they're protective of the other uses. Bedrock, there's a big piece of Protocol 21, and I hope everybody's read it because we put so much work into developing P21, but a big part of it was actually clarifying and simplifying the language. We spent a lot of time working on the language in Protocol 21, and one of the sections that was really skimpy and unclear, we got lots of questions, was on bedrock. So we clarified mapped aquifers. So mapped aquifers on the ministry's aquifer on IMAP. If you go onto IMAP and you set up the layer for aquifers. I've got a couple of slides here showing that. Then if those are mapped in bedrock, they're a drinking water aquifer. This is the tiny little tightening that we've done. So for bedrock, instead of using hydraulic conductivity as a measure of whether you have an aquifer or not, you can only determine, when you're actually in the process of assessing whether bedrock has drinking water use or not, you can only determine that on the basis of yield. So you need to do some kind of yield test, pump test, or there may be, we're probably a little lacking on guidance around that, but if you have any questions, give Annette Mortensen and Amy Sloma, who are the leads on Protocol 21, a call, because there's guidance in various places. So the other thing about bedrock, so here's the positive side of it, you can use data from 500 meters away. So that one's a big one. We really don't want people drilling tons of holes in bedrock. It's expensive, and if you do have any deeper high-quality zones in that bedrock that would be capable of supplying drinking water, we don't want to be breaching any overlying confining units in the bedrock. That applies to the natural confining units as well, actually. We're trying to minimize the number of boreholes that are drilled through these important barriers. So you can use data from nearby sites. Natural confining barriers, we introduced the recommendation that came way back in the early days from the working group. I think I saw Reg North, he was on that working group, where it was maybe your idea to do this equivalent thickness for the natural confining barrier. So you can, we just have a correction factor if you have a higher conductivity but a thicker natural confining barrier. If you can demonstrate on the basis of this correction factor, you're just correcting it back to the standard of 5 meters and 10 to the minus 7. If you can demonstrate you have that same protection in a thicker unit with a slightly higher conductivity, then that would qualify as a natural confining barrier. It turns out, thickness and conductivity vary differently, so you don't get a lot of relief on your conductivity, but you do get some. And sometimes people find very, very thick low permeability units. Free of contamination, we used to require you to collect groundwater samples. That's just not the way to go in clay and silts. We often find, we often have whole investigations that were triggered as a result of just making a determination of whether you have a natural confining barrier or not. And that's just a function of, the fine-grained particulate and the high aluminum, and it's just an artifact of sampling in fine-grained units. So now you can determine whether a natural confining barrier is clean on the basis of soil data. And we will update that when we have the omnibus come through. Right now, we're pointing to different schedules, and if there is no soil standard, then you're stuck having to determine that the natural confining barrier is clean on the basis of groundwater data. And for DNAPL, any DNAPL substances, you're going to have to do a water sample. And then the biggest one that we added right at the very end was this filled marine and estuarine foreshore. So any area that's below the historic tide line, it's out. And for the entire profile, it's out from this future drinking water use. Whoever's, Andrew, can you keep me on time here? Because I have a feeling that I got a few too many slides. Just give me a 5-minute, maybe a 10-minute warning or something like that. Yeah. Am I? I have 10 minutes. Okay. So I'm not going to spend time on this slide, but we spent a lot of time on the flow charts, just like we did on the language. Maybe if you go down, and we haven't got the upper question here is, are you an aquifer based on your conductivity or your yield? But once you go down the confined aquifer path, there's a question here which is introduced in this new version, which is the aquifer average saturated thickness greater than 1 meter? So if you're in if you've got a sand seam in a predominantly fine-grained material that's less than 10 to the minus 6, we're not going to call that an aquifer if it's less than 1 meter thick. So that's a relief too. And the unconfined aquifer evaluation, it just makes it really clear that you have to have that natural confining barrier underneath, or you won't be able to assess that pathway separate from the deeper aquifer. Here's the map that we love. It turns out this red line doesn't extend in this report, Vancouver's Old Streams, beyond much what I've provided in the slide, but it's still an area with a whole lot of contaminated sites that have been investigated to date, and probably a few more that people are working on right now. And you can see False Creek Flats is completely out. So that was a big waste of time having to do all those water use determinations for False Creek Flats. And of course, along the Fraser River and New West and Burnaby, there'll be areas that will be eligible for that exemption. So just really quickly, the two processes in going through Protocol 21, you can meet the criteria that are in the protocol, and if that exempts you from, and let's just distill it all down to future drinking water use, that's the most stringent of the pathways. If you can show that drinking water use future drinking water use doesn't apply, then you just need to present all the data and your arguments in your DSI. You need to summarize that in your summary of site condition. Want to make that really clear. And there was a bulletin that went out very recently that reminded people of the need to put that information in the summary of site condition. We still review those summaries of site condition, and people here have been contacted even in the last few months about missing information. And then if you don't meet the criteria for an exemption under P21, you can seek a director's determination. If you really are in an area where all evidence would suggest it's unreasonable to anticipate future drinking water use, then you put your data and arguments in an application for a director's determination. And there's some guidance. It's kind of a weight of evidence approach. And there's guidance in Appendix 1 that will point you to those factors that the director puts weight on. And they really are the quality and the productivity of the aquifer first and foremost. And then there's a third category of demand. So just a status, we've had 4 applications for director's determinations in 2016. That's way down from the past. And so where are we going? Right now, we're just watching and monitoring what kind of relief is happening under Protocol 21. We're still capturing data because we want to build it into our future mapping initiatives. And we're processing the determinations as they come in. So just quickly on the groundwater mapping piece, We would really like to proceed towards mapping in a way that has some real usefulness for our stakeholders. So short term, we are trying to get hydrogeological data in a mapped format for use to augment site-specific assessments under P21. And of course, you can use the bedrock data within 500 meters. Actually, in TG6 now, it says you can even use data for unconsolidated materials within 500 meters, but you can only use it to augment your site-specific data. But you'll get your stats, you know, if you have more wells, then you get to look at your geomean instead of your maximum. So it makes a difference on the stats. Long term, we would like to just map out the geographic limits, you know, DW and no DW. Wouldn't that be easy for everybody? And it would be consistent, and it would reduce the time and cost for everybody. It's a pipe dream, really, but, you know, we're kind of chipping away at it. And this just points to some of the available mapping, and I'm going to just run through those slides really quickly. This one's interesting. So this is off the wells and this is off IMAP. So I've mapped the well layer and the aquifer layer for Vancouver and for Surrey. So the aquifer, everybody knows aquifer in Vancouver is that quadra sand aquifer. It's actually a really decent aquifer. It's unconsolidated, moderate productivity. It's overlain in most areas by Vashon Drift, which is kind of, maybe it seems like it qualifies as a natural confining barrier in some areas, but we've seen a lot of contamination in the sand seams in that drift over the years. But it may in some areas, and appears to qualify in some areas as a natural confining barrier. Those wells, I checked a lot of those wells because I was very curious. I think there's a few irrigation wells on golf courses. I'm sure those wells out at UBC are being used for irrigation. The wells along Broadway, those are old 60s wells. The Vancouver sewer district, I don't know what they were using the wells for there. Surrey's really interesting. Look at all the wells in Surrey. I think that reflects the history of Surrey. I suspect those wells, the majority of them aren't being used anymore. That kind of predated the water supply from the city. I have no idea. But I know Carrie Barron has always said that groundwater is a serious resource in the city of Surrey, and it is used. And it's a nice aquifer. That's a high productivity aquifer. Overlain, again, by tills, thick sequence of tills. So in many areas, maybe most areas, it's actually a fully confined aquifer. This is a little piece of mapping, and I don't have time to get into it here, but we did a pilot study with Worley Parsons to try and extract data from the wells database. There's a lot of data there. The only problem is where the wells database has lots of data. It's in areas where drinking water wells are, so it's not helping us along the margins. But it just shows, you can see on this figure on the right-hand side on the legend, it's showing probability. So the red is 0 probability and green is very high, okay, 1, probability of 1. So the green would be your aquifers, and these are slices, 2-meter slices. They've transposed all those odd definitions in the drillers' logs, like hard pan, and you know, that kind of stuff. But anyway, so this has potential, and a recommendation coming out of that was combining our data with the wells data, and we've been talking about that with our colleagues. Here's our borehole data. This was a project that Lavinia is responsible for. We had a great co-op student do this. So here's Vancouver, and it shows the color coding is the depth of the boreholes. There's 900 boreholes there. We're collecting boreholes. Thank you, everybody who's sending your borehole in with all your applications, because that data will eventually get uploaded. It's being collected right now. And then the next figure shows that 215 of those borehole logs had conductivity data, and so here's the legend that goes along with that. The lithologies, there's really good information here on IMAP. So go under I think it's under waste, which is an odd place for it, but that's what we are. And then it's borehole lithology, I think is what the layer is called. And then you can go in and look. This is like 7.7 to 9.2 meters depth, and there's a soil description there and a conductivity, so it was screened at that depth. 10 to the minus 5, so that's pretty permeable. Moving along, here's your database, and this is Peter Reed. I don't know, I don't see Peter, but anyway, this is Hemera's work that they've done for CSAP, and this, I just plotted this the other day, so you can see that in that area, and here we're talking about target areas for doing, just blocking out no drinking water use. We're really looking at downtown Vancouver. We have lots of, it's not a mapped bedrock aquifer. So that area, clearly is being identified as no drinking water use based on site-specific investigations. And then you can see some along the Fraser River. So we haven't made any progress on our mapping project, but we keep advertising that we want to move it forward. Thanks again for the boreholes. We're working on consolidating the wells in our database and exploring partnerships. So I have 5 minutes to finish this section. Okay, I'm going to keep going. Hopefully Alan's going to have time. Alan's going to have to speed talk at the end here. Okay, so draft protocol 5, this is our groundwater remediation requirements. This has kind of been on hiatus, but not really. We've been having discussions with our water colleagues, and there was a working group that was run by CSAP with numerous stakeholders being part of that working group. And Guy Patrick led that group and provided recommendations to us to consider for our next iteration of Protocol 5. So let's look at the roots in the legislation. Here we're pointing to, this, like we're really going into the fundamentals, Section 56 of EMA, where it talks about remediation. A director must consider and responsible parties must give preference to alternatives that provide permanent solutions to the maximum extent practical, and taking into account a variety of factors. So I won't spend any more time there. And of course now we have Living Water Smart and Water Sustainability Act, which has a section on water objectives, and regulations are going to be developed over the next couple of years around those water objectives. So those are the direction there. The intent is to ensure the remediation of viable aquifers to the extent practical to support applicable water uses. And the protocol, I'm not sure if it's in the protocol, but it's in Procedure 8. The protocol is relying on this target called a remediation concentration goal. And that is a concentration in the water that must be met, is considered to meet the remediation standards of the CSR. It could be a numerical standard, a site-specific numerical standard, a background concentration, or a site-specific risk-based concentration. That's also defined in Procedure 8. And I've kind of distilled it down to back-calculated concentration that assumes a complete exposure pathway. So for water, it's either you're drinking it or you're not drinking it. So that's the site-specific risk-based concentration that would be developed, would be assuming the water's being drunk. The protocol is really a process of how long you get to be between contaminated groundwater and usable groundwater. So, the middle ground there, the administrative controls, that's really where the protocol is providing guidance on where you would fit in that really timeline. How long do you get between contaminated groundwater and clean groundwater? Right now, it maps out kind of a hierarchy, starting with the most conservative being short-term remediation. So, I just did what I wasn't. My little animation. But anyway, the short-term remediation is where you have current use and you don't have an impacted well, drinking water well. If you had an impacted drinking water well, you'd be in there right away cleaning it up. So this is where you do have wells within 500 meters. And you would be cleaning that contamination source and the plume to meet the remediation concentration goal within 5 years of issuance of the instrument. So you remember there's off-ramps all along. If you have a feasibility assessment and you've got some agreement with the affected parties or whatever, there are ways to demonstrate that you would qualify for a longer-term remediation strategy. That's kind of how the scheme works. but it starts at the most conservative level. So the long-term, there's 3 long-term remediation strategies. So A and B are variations on the same theme, and all of these strategies involve removing the contamination source, but recognizing sometimes that's easier said than done. There's often a residual phase that's left. So these longer-term options are remediating the contamination source in the plume to meet the remediation concentration goal for the entire site, or for just those affected properties, leaving the source site to be managed under risk controls, and within 20 years. So now we're talking about the M&A solution, or the enhanced. So there you go. That's like this. So you've got a little bit of residual left, but you pulled the plume back within the property boundary. That's option B. And then C is, if none of these are feasible on your site and your conditions are such that it's technically impractical to achieve a 20-year time frame, or whatever the conditions are, then you can make an application to the director and present your feasibility assessment to justify an alternative approach. And then one thing that we added in, and this was thanks to CSAP's contribution, they were aware of the California approach, which has this, we're calling it a limited use aquifer, but it's, they don't call it that down in California, but that's what we've called it. And it is an easy off-ramp for petroleum hydrocarbon sites, because we know that they are readily biodegradable, on marginal aquifers. So eligibility criteria would be marginal aquifers with no current use and limited potential for future use. And petroleum hydrocarbons keep the concentrations below 10 times the standards, and you've got a demonstrated trend, biodegradation trend. So your relief would be closer to the current situation. You know, your monitoring time frame could be cut off early, and you would just manage the residual contamination over time using groundwater, institutional control. Groundwater must not be used for drinking. So just to get out of here and leave Alan time. So we picked this document back up. And Steve Dankovy and Annette Mortensen are leading it, and we will be hoping to finalize the draft for public comment by the end of the year. And again, like I said, we're working closely with our water colleagues on ensuring there's alignment between the objectives regulation that they're developing under the Water Sustainability Act. We have a lot of work to do. There's a lot of issues with this document, and you know, I have to be honest. We still have a lot of work to do, and I'm sure we'll get lots of comments when we finish the document. And I'm not going to talk about TG22. Except to say, oh, I do have to say, CSAP had a contract. Ian Hers for Golder did just a huge amount of work on a toolkit for evaluation and monitored natural attenuation and natural source zone depletion, of which Protocol 5 doesn't allow. But huge amount of work, really excellent documents that were produced by CSAP. Thank you very much. And the federal government have just released their draft guidance for monitored natural attenuation. I think they finally got it translated into French, because it says 2015 and we just saw the draft a month ago. Thank you.